Alright, hey everyone. I'm just streaming here. I thought I'd do a little bit of calculus notes and just take a look at some problems. So I'm sitting here and I'm thinking about domain and range for functions. Here's that can go into a function. That's the domain of that function. And here's everything that comes out of the function. That's the function, the range of it. So right here we take an input, we pass it through that function f, and we get f of x, the output. X goes in, f of x comes out. And if I have a function that looks something like this, some quick axes, and here's a quick little function, then this height right here, that's our range. And then this, let's pick green, from here to here, this width, that's our domain. Now we can have holes in them, and we're typically going to be dealing with holes when we have 0, or if we have square roots of negatives, since we're working on the reals. Okay. Let's see here. There we go. So let's take a look at those two examples then. I want this color blue. And let's let f of x be equal to x squared minus 5x plus 6 all over x minus 3. I'm going to look at the domain and the range of this. For the domain, it's not a D. There we go. For the domain, we're thinking no division by 0. So that means that x minus 3 cannot be 0, which means that x cannot be 3. So we would say that the domain of f is equal to the set of all x such that x is not equal to 3. Cool. The range is a little bit trickier. We got to see what can come out of this function. And for that, I'm going to take this f of x right here. I'm going to factor it. And this top factors into x minus 3 and x minus 2. And it's all over x minus 3. These then reduce. So we'll be left with x minus 2, which is linear. And something that's linear maps R to R, takes all the reals and spits out all the reals if we've got a line. But there's a gap when x equals 3. Three minus 2 is equal to 1. So gap for f of 3 equal to 1, or y can't be 1. So we'd say that the range of this function is equal to, and our book seems to like the set of all y such that y cannot be equal to 1. if we want to get all fancy, and sometimes we do, we would say that it's equal to the set of all real numbers, take away the set 1. All right. Here's another one. Let's take a look at g of x equal to the square root of x squared minus 10. So what we've got right here is the square roots. That means no negatives. So we're going to... What the crap? Weird. Oh, internet's working. I get the feeling this video is going to end up being deleted, but that's okay. Let's take a look at the range of this. I think some people find it easier if you take and you say y is equal to the square root of x squared minus 10. You let the output be y. So then we would have y squared is equal to x squared minus 10. Y squared minus x squared, no. Let's make this 0 is equal to x squared minus y squared minus 10. Let's make this 10 is equal to x squared minus y squared. Because then over here, this is greater than 0. So then we just go ahead and we divide, and we'll get 1 is equal to x squared over 10 minus y squared over 10. Hyperbola. So what does that mean for our range? If we've got a hyperbola, range of g is equal to, it's totally an r, the set of all, sure, we'll use y such that, y is an r, just all real numbers, I guess. So we could say a set of all y, or we could just say it's r. I prefer to just call it r, it's all real numbers, because remember what a hyperbola looks like, it goes down like that, comes up like this, hyperbola. Alright, that should be it for this test video. I will see you later.